welcome to Desk of Lady Ada.
Hey everybody, and welcome to another Taco Tuesday. Desk of Lady Ada. I'm full of tacos, and so's Phil, floating skull over there. Hi, floating skull. And
I had cactus tacos.
Yeah, cactus tacos.
I had no fun with my tacos tonight.
Yeah,
but it was okay. It was okay. They were made out of cactus.
We had plenty of sangria. But tonight we're going to show what I did before I did the tacos, which is bring up the TRINKET M0 Rev B. So, for those who remember, a couple weeks ago, I was working on this TRINKET M0. It's a SAMD processor on a TRINKET size circuit board, compatible basically with the TRINKET and compatible, but way more functional, has a lot more capability. And I made a mistake in the last design where I accidentally tied V-core to VDD, and I forgot that the core voltage, the core voltage of the SAMD processor is 1.8 volts, not 3.3 volts, so by tying it to 3.3, I kind of like messed it all up. And I cut a trace, and I got it up and running, but I wanted to respin it, of course, to test it out. I also moved a couple pins around. So let's look at the new design. So we can look at it maybe on the compy.
Yeah.
Okay, so this is the TRINKET. Let me turn off stop layer. A little bit clearer. I'll turn off the bottom placement. So you got your ATSAMD 21E processor. So that nice Cortex M0 Plus processor here. Oops, this is supposed to be here. Yeah. So there's a RGB LED over here, SPI controlled RGB LED, the APA 102 in 2020 format. And then here's the trace that I fixed. That's the V-core trace. Going to a 1 microfarad, another 1 microfarad on 3.3, 10 microfarad on 3.3, 3.3 regulator, diodes for VBAT and USB, so you can use either and you don't have to worry about back powering.
I got a question.
Yeah, what's up?
It's not my question. It's a question from the internet. Why is the SAMD so cool?
It's cool because it's Arduino compatible. It has support in the Arduino IDE. It's got a lot of peripherals. It's got I2C pins, SPI pins. It can be set on any, muxed onto any port. It's got a ton of RAM, 32K of RAM, a ton of flash, 256K of flash, and it's cheap. This chip, I can get this chip for probably about $1.50. And it has all these nice things, for example, there's no crystal here. One of the previous shows, a couple weeks ago, I removed the 32 kilohertz crystal. So there's no crystal. What it does is it automatically syncs the clock to the USB start a frame pulse. So basically, the cost reduction is intense. You don't need series resistors on USB. You don't need a crystal. You don't need any diodes on the reset pins. Got internal pull-ups, pull-downs, analog outputs, 10-bit analog output. All of these are analog inputs. All these can do interrupts. All these can do PWM. You can have I2C serial. There's so much functionality, and it's cheap. And I like the Atmel chipsets. I think they do a good job. I mean, the ARM core of course, comes from England. It's popular. You can get ARM Cortex M0 from ST, from Atmel, from TI, probably everybody. Everybody's got their own Cortex M0 chip. Nordic, put the Bluetooth on there, and now it's the NRF series. But I like these. They're inexpensive. They're easy to use. Very well documented. The ASF chips, the chip framework library, is very easy to use. The compiler works with this, standard GCC EABI compiler. It's just it's super chill. I find it all very well documented and easy to use.
Okay.
Lots of example code. That's why I like it. Got a reset button down here, and then same size overall. What I did is I had to make these resistor LED, this set over here, 0603. So this used to be an 0805 resistor and capacitor, but I actually did run out of space. I couldn't quite fit both of these in here. I mean, maybe if I really wanted to, I could squeeze everything down, but I was like, you know what, I have space, and it passes DRC. So I can even move this over a little bit to the right to keep it away from that edge. But as long as you keep it away from the break point, which is over here, this is where it's going to shear off of the panel. Just keep components off of that edge. I might move this back down a little bit, and it should be fine.
Yeah.
Okay. So yeah, so with that fix, so I've got my jig. So let's go to the overhead. This is my little SWD jig. So I cut it on the other mill, which is really handy because you just basically take the design you've already got in EagleCAD, and then you just put, wherever you have test points, you just put a through hole pad, and then you just pop a pogo pin underneath so that it matches up. So we've got the SWD and SW clock pins on the bottom, which is normal. Like I don't want to use those for anything else. I want them to stick for programming only, so they're on the bottom, and then the rest of the pogo's connected to power and ground. So you can just, for now, I just hold it in place.
Yeah.
Later on, I can.
What people don't see is how tiny this trinket is.
No, they do. They see my hands.
It's super tiny, though.
It's tiny.
Yeah.
Okay, so let's go to Atmel Studio.
Yeah.
So what I did during this afternoon is I updated the bootloader, and let's see if we can find it. Okay, so the bootloader, so it's all programmed. So can you
Yeah.
go to the Iranian?
Yeah.
Yeah, so it's verified flash. Okay.
Bonafide.
So we've still got that pulsing LED here, which is like kind of the standard bootloader. It's going to be this little bright. I'm going to probably make this higher resistor. But there's this little RGB LED here, and I made it so when it enumerates, see, it does a little bit red, green, blue, very fast flash, and then it turns into a pale white. It seems really bright. It's not nearly as bright as it looks under this lens. It's a pale white color, so that lets you know. I can show you how not bright it is if you hold it up. So it lets you know that it enumerated. And the issue is a lot of people end up using sync. They don't use sync cables. They use charge cables. So, for example, this is connected to connected to a power regulator. It's not connected to a computer.
Mm.
So when that happens, it pulses, trying to enumerate, and if it doesn't enumerate within 6 seconds, it'll do this little warning. So that lets me know and the customer know that, like, hey, it didn't enumerate. That's why you're having problems.
Mm.
So if you don't get that RGB flicker and that white, it means it didn't enumerate. So that's kind of going to be helpful, because before it pulsed waiting for enumeration, because it was waiting for like UART maybe, or as an option, because it was UART or USB. I took out that UART test and I just made it look for enumerations. This is like, hey, your enumeration failed. It'll just wait here until you reset, and then gives you about 6 seconds. This is looking good. So I kind of like that. So you get a little, you've got an RGB LED. You might as well take advantage of it for the bootloader. So I added a little bit of code for that. So it's kind of nice. So red, green, blue, flicker.
Most of my life is hearing ba-dum-ba-dum,
I know.
ba-dum-ba-dum,
And then
ba-dum.
I put together a little demo, because what I've got here is there's 5 pins total. On the right, these pins can do I squared C, and on the left, these pins can do UART. And then there's one more pin, which I can do actually analog output. So I wrote a little demo for this, which would test both, right? So you want to test both boards. So this, I gotta load it up because I think I changed it. It'll take GPS data from here and then print it onto the OLED. This is a good test of I squared C and serial. So let's go to the copy. Okay, so this is my demo. And what's nice is, I got all this like extra stuff. Let me delete all this extra stuff.
I don't need that.
Yeah, I don't need this. So what's nice is you get that serial one that you know and love, hardware serial port, and then I just instantiate my GPS and say, hey, that's my serial port. And then I use the A0 pin for the OLED reset. Kind of nice to, if you reset it, you always get a nice clean display. And wire is also default. Like wire and serial are on those 2 pins. If you don't instantiate wire or call wire begin or serial begin, those pins don't get used. But if you do, you get hardware serial and hardware.
We have a question from the chat. Will there be a pro version of this new trinket?
There won't be exactly a pro version of this trinket. There'll be something a little bit different. Yeah, I think the feathers are kind of like, there'll be something a little bit bigger than the trinket. but I can always design something later. But I wanted something to replace the Trinket because the Trinket's so popular, but not having native USB and not having all that, like having so few pins that you can use was really frustrating. So what's nice about the Trinket is the LEDs on a different pin than the RGB LED, which is on different, like everything's on different pins. So you don't have to worry about colliding.
Don't worry about that.
Whereas on the normal Trinket, 2 of those pins are used for USB and then 1 pin is used for LED. So you don't get that many pins, and also it doesn't always enumerate very nicely. So this demo just, gets the hardware serial going, sends the commands, and then reads data from the GPS serial port. And then while it's available, it prints it to the display. And when it gets a $ sign at the beginning of a GPS statement, it clears the display. So it's just going to display 1 sentence at a time.
All right.
So you get the Trinket M0, and it's got the location. So upload.
Yeah.
You can go to the overheads. It's going to wait. It's going to compile the whole thing.
Doop, 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 doop. Look, there's there for logo. Something's happening. Something's happening.
Okay.
Hey, look.
So there you go. Yeah, so now it's just printing out. You can see it's a 4K display. So it's just printing out all of the sentences. So I know this worked because I had to send the command to the GPS to tell it to only display RMC sentences, which it's doing. And then it's getting the data, and then it's displaying. So I know all the pins work. This is a nice little demo of, first off, functionality. Right? You want to make sure that you can do these kinds of projects, which is, what's neat is this used, let's see how much space it used. This is a 16K of flash demo, and it's got the USB UART as well, and it's only using 5% of the program space. So this is what normally on a Trinket would be impossible. Is very easy, and you have tons of space. You can have extremely complicated projects, not a lot of pin usage. Maybe you don't need a lot of pins. Maybe 5 pins is enough. Especially since you get that RGB LED on there. So if you wanted to do some sort of indicator, like if the GPS was not having a fix, or you have some other sensor data, you would have
the smallest, cheapest way to do stuff.
Yeah, it's super small.
Oh.
So I guess the next thing I have to decide is whether I want to stick with a 16-volt input regulator or go to a 6-volt only regulator. If I go to a 6-volt only regulator, I can power a lot more stuff.
Yeah.
Which I might do, because I think that not a lot of people end up using high voltages for their regulators. I think they tend to use like AA's or AAA's, and they stay under 6 volts. So the trade-off is if I use a 16-volt regulator, it's going to be tougher for me to get a regulator that can give me the 200 milliamp, 300 milliamp out. So if I wanted to add, this could actually control a Wi-Fi device or something,
Yeah.
or cellular. Can't do that as is. Like a Wi-Fi, like an ESP chip or a Wink 1500. With 5 pins, you can control a Wi-Fi device, but you can't do that with the regulator. So I have to decide, this is my decision now, is do I want a high voltage or do I want high current, or I can go with the SPX 3819, which is both, but it's pricey. So that's kind of that's what I did today.
All right.
Nice.
That's the desk of Lady Ada.
That's my desk.
Yeah, that's it for Tuesday.
Super easy. Taco Tuesday, and then next up I'm going to get these gemmas up and running. So put the bootloader on here, same bootloader. I'm not too worried about it. Just going to solder some wires onto the SWD pins. I didn't make a jig for this because I worked on the Trinket more than the Gemma.
Mm-hmm.
And then maybe put a bootloader on it, and then maybe we'll get some MicroPython tested on it, and I'm going to also do a project like this. It's a project that uses all the pins. This one it only has 3 GPIO. It has an analog output, and then 2 other pins which can do serial or I2C. I mean, it's very simple, right? You get 3 pins, you can do serial or I2C, or your glasses on. You can't do SPI, of course. You can do analog ins. But I think for like most Gemma projects, maybe we'll pick a Gemma project that was a little challenging, and we'll redo it with this chip. You know what I should get actually is an FFT library for the SAMD. I gotta find that, because then I can do audio effects project. You know, one analog input for audio and then NeoPixel output. But yeah, so far, like, the Crystalless bootloader and Crystalless runtime have been working out great. So the next step is for me to send, once I, of course, validate this, and the hardware's good, send this for FCC CE non-emitter certification, and then I'll be able to sell it.
All right. When do you think it's going to be in the store?
Probably early next year. I mean,
Ooh.
yeah, I have to do a little bit of work, and getting that certification takes a couple weeks. Probably mid-January.
Okay.
I'll get it ready. We'll see. I'll rush these out. I'm going to send the prototypes out for the FCC test, which is always kind of nice, because, like, you know, it's going to take a couple weeks, and by the time that's done, because it always passes. Like, there's nothing on here. There's, like, nothing going on these. The traces are all very short. There's no motor control. There's no power regulation that's switching or whatever. So I'm confident that I can get the PCBs made with the FCC logo, hold on to them, wait for the certification, and then once I get the certificate, we can sell them. It's a little risky, but I've done this before, so I want to take that risk.
Okay.
Okay.
So tomorrow night,
Yeah, we got the shows.
we have
Real shows.
3 Thursdays. Show and tell.
3 Thursday, which is on Wednesday. Show and tell.
Ask an engineer. It's happening.
Yeah.
All right.
Maybe I'll have my Gemma up and running by then.
Okay.
Sure.
Do you want to? What do you think you're going to show tomorrow? For It's Not Out Yet. Don't ask.
I don't know. Maybe this Gemma and Trinket.
Yeah.
Yeah.
With the matte black.
Yes.
CDs. Well,
Blacker than black.
all right. All right. That's it.
Okay.
All right. Later, folks.
Bye.
All right. The code is whoops.
Whoops.
Support open source hardware
Whoops.
and companies like it for it.
Yeah.
You know what you need? You need a capacitor.
Capacitor. You know you need. You need a capacitor. Capacitor.